Hi guys, our easy to follow maths video is on bearings and trigonometry. So applications of SOHCAHTOA to questions set using bearings. Here's example 1. A ship sails 100 kilometers from a port P on a bearing of 140 degrees. So to understand this question, we need to understand what a bearing is. So very quickly, a bearing is measured from the north and it's measured in a clockwise direction. So from that north line, we want to be measuring 140 degrees clockwise, and that would be our bearing. And it tells us that the actual distance travelled is 100 kilometers. So on this length here, we'll put 100 kilometers in. Now the question is actually saying how far south of the port is the ship now. So the ship's here. We know it's 100 kilometers away, but where the port is, where the red blob is now, how far south is the ship? So that would be this distance straight down, because that would be south from the port P. So it's this distance here. Okay. So what we would do, we'd mark in the distance south. Okay, and to complete our right angle triangle, we draw the distance across as well to the ship. So in this right angle triangle here, we have one length of 100 kilometers. We can now find this angle here. This straight line is obviously 180 degrees. This part of the angle is 140, which will leave a remainder here of 40 degrees. So now in our right angle triangle, we've got the hypotenuse of 100 kilometers and the adjacent of y kilometers. We're in business. So cosine 40 is the adjacent over the hypotenuse, which would be y divided by 100. So in order to find y, I need to multiply both sides by 100, and that gives me 76.6 kilometers to 3 significant figures. In part B, it asks how far east of the port is the ship. So there's the port, there's the ship. East would be horizontally to the right, which is the same as this distance here, which I've marked in as x. So in our right angle triangle, we've got the hypotenuse of 100 kilometers, and we want to find the opposite side. So the ratio that uses the opposite and the hypotenuse is the sine ratio. Sine 40 is opposite over hypotenuse, so that would be x over 100. And if we want to leave x on its own, we need to multiply by 100. And then our answer, rounded off to 1 decimal place or 3 significant figures, 64.3 kilometers. Here's example 2. Again, it's a ship sailing from a port. So there's the port and there's the north line. So remember, a bearing is measured from the north line in the clockwise direction. So 210 degrees round in the clockwise direction would be that direction there. Now we want to know how far south of the port is the ship. There's the port. So south would be straight down, okay, along the line of the ship. So it's this distance here that we're looking to find. Once again, we form our right angle triangle, and if this is 210 degrees, this angle, then this straight line would be 180 degrees, which would mean this bit of the angle left would be 30 degrees. So we've got the hypotenuse and we're trying to find the adjacent. So the ratio we would use is the cosine ratio. Cosine 30 is the adjacent divided by the hypotenuse. So we put the adjacent in of y, the hypotenuse is 240. Now we're trying to find y, so we need to get rid of this dividing by 240. So we multiply by 240. So 240 times cosine 30, rounded off, and that's 208 kilometres. Now in part B, if it had asked for how far west of the port is the ship, so there's the port, there's the ship, west is horizontally to the left, so it would be this distance here, which is the same as the distance x marked on in the triangle. So there's our 30 degrees. This time we've got the hypotenuse, but we're trying to find the opposite, so that would be using the sine ratio. So sine is opposite divided by hypotenuse, so that's x over 240. Multiply both sides by 240, and that gives us a distance of 120 kilometres. So that's how we apply trigonometry, SOHCAHTOA, to bearings questions. But you do need to understand what we mean by a bearing. It's an angle measured from the north in a clockwise direction.